Good day everyone, I'm Engineer Shane and today I'm going to discuss about the topic structural engineering. For our learning outcomes, by the end of the discussion, students should be able to explain the role of a structural engineering, identify basic structural loads and their effects, apply basic concepts of structural analysis and design. Now let's answer the question, what do a structural engineer do? As you can see here on the blue shapes, we have four processes on what should a structural engineer do. This is a process. So with that, the first one is preliminary study. Second is doing analysis. Next is designing. And then last is construction. For the preliminary study, first that we need to do is to conduct a site investigation. So with that, what does that mean? You will need to check the actual site conditions, meaning looking at the terrain, whether there will be an existing structures, there will be a drainage, accessibility, and other factors that may affect the design of you as a structural engineer. The goal is to understand what the engineer is working with before designing. So same with, if you're gonna do something, you need to know what there is first before you start doing action. So what are the guide questions that we can use? So before designing, while conducting site investigation. First, is the site flat, sloping, or irregular? Definitely, it will be an advantage if the slope or the terrain will be flat because the structure you will be building will be flat on the ground. If sloping, you will need another consideration in terms of designing. Second, are the areas with noticeable elevation changes? Definitely, if the structure that you will be designing will be up on the mountains, it will be in a different setting, unlike if it's in the flatlands, wherein it is more accessible and easier. Next, is there evidence of soil erosion, settlement, or instability? Nowadays, we're in the Philippines, weather is unpredictable. We also need to consider if the structure that we will be building is prone to soil erosion, prone to settlement, whether underground, what is the type of the soil profile, or there will be instability once you build the structure. Definitely, as the client, you need to ensure that as a structural engineer, you need to ensure the client that the structure that you will be designing will stay on time, will be built with integrity. Not in after a few years, it will not be in use. So with that, it's our role to ensure the client that everything will be okay. Next question, will existing structures be demolished, retained, or connected to a new structure? As a structural engineer, you also need to consider if the location or the lot of the client has an existing structure or none. If there is an existing structure, you need to know if the structure will be demolished or you will continue building from the existing structure. Why does it matter? It matters because if there is an existing structure, you need to abide with how the previous structure is designed, and you need to design according to that for the new structure. You cannot not consider the existing because eventually, as per the client's perspective, it should be aligned. If the previous structure will be demolished once you construct the new one, it will not be purposeful as well for the client. So you really need to know. Third, next, are there nearby buildings that could affect during construction? The consideration for this will be if the lot is tight, meaning if the neighborhood from both sides, from the front and the back of the lot of the client has neighboring structures, you also need to consider if it will not compromise the living of the neighborhood, or it will not or the construction will not affect the structure itself. Because if it is, it will be a problem for the client. So that's why, as a structural civil engineer, you should consider if what are your means or options if you have neighboring structures already. Next, Is the site prone to flooding or ponding? As mentioned a while ago, in Metro Manila, most especially, flooding is frequent due to poor drainage system. That's why if you will be building here in Manila, you should consider make it higher or providing an appropriate drainage system, and make sure that your design drainage system will be working well if you tap it in the public drainage system or the existing drainage system. If not, you need to design it as well. Next, can construction equipment and delivery trucks easily access the site? In terms of construction, as a structural designer, you also need to consider the materials that you will be using, because if it will affect the design and the construction of your design, it will definitely affect the client's dream for the structure. Next, where can materials and equipment be stored? For the situation a while ago, if the lot is too tight, no extra spaces for storage, you also need to consider that as a designer, because it will not, the design will not happen if the materials are not well properly stored. Are the overhead power lines or underground utilities? So you also need to consider if there is an overhead power lines in terms of the height of the structure, or there will be affected underground utilities if in case you will be doing foundation works. Next, are the trees that may affect construction or foundations? In reality, you have some considerations for this one. You can retain the trees or you can pull it out. If you will be retaining the trees as structural engineer, you need to consider if the roots or the trees itself will not affect the structure that you will be designing, because if the trees will maintain planted and the trees will continue to grow, definitely it might affect over time the structure that you will be building on that lot. On the other hand, if you will be pulling out the trees, you will need to apply for permit to the DENR before you do the cutting of the trees. Another one for the preliminary study is to have a soil analysis report. As you can read from here, geotechnical engineer is the one who will investigate the site through soil exploration and testing, while the structural engineer will review and uses the information that the geotechnical engineer given through soil analysis report when designing the foundation. Do not assume as a structural engineer soil properties or proceed with foundation design without adequate geotechnical information. Why? Because if you will be proceeding with structural design without any information about the soil profile, with the concept that all of the buildings are built on soil, it will be a higher risk that the structure that you will be building will not be in accordance on the location, because you don't know what is the soil profile where you will be designing your building. So I hope that is clear. Geotechnical engineer provides the essential information about what the foundation is sitting on or about the soil profile, while the structural engineer designs the foundation. So with this step, it is a collaboration between the structural engineer and the geotechnical engineer. For the process, the geotechnical engineer will be doing the soil analysis first, then the structural engineer can proceed on the next process. Analysis. So here, as a structural engineer, you need to know what are the different types of loads. So here are the common types of loads that you will be encountering as a structural engineer. So with that, it is divided into vertical and horizontal loads. While under the vertical loads, we have dead load and live load. For the horizontal, we have the wind load and the seismic or earthquake load. So for the dead load, from the word itself, it is dead. It is a permanent static load. Examples of these are the weight of the structure, itself. So you also need to consider the weight of the structure vertically going downward due to gravity, because it will be part of the force that we will be transferring to the soil. Next is the live load. If there is a permanent load or dead, which is not moving or permanent, we also have the live load. So the live loads are temporary or movable loads acting on the structure. Again, the force is always downward, vertically downward. Example of these are people, furniture, and vehicles. Because, for example, in a classroom, you can have one student with full of furnitures. So with that, it can be full of 40 students with 40 seats or 40 furnitures. So with that, the classroom, the structure itself, should be designed with its dead load, also with how many will be the live load. So as future structural engineer, you need to consider what are those dead and live loads. Next, horizontal loads. If there are vertically downward loads, we also need to consider horizontal ones. So when we say horizontal, no, this position. So for the wind load, the concept is the higher the building, the higher the pressure. The lower the building, the lower the pressure. Why? Because the higher the structure is exposed above the ground, the higher the wind load will be. Okay, I hope you understand that, the concept of that. So that's why for high-rise buildings, for skyscrapers, for buildings that are taller than 10 floors, 15 and up, wind load is much considered because the higher floors will more likely to receive more or higher wind loads. Okay? They are more exposed to the atmosphere above the ground. On the other hand, since all of the structures are built on soil and earthquake is manifested on soil, all of a structure will definitely experience seismic or earthquake loads, whether it's just a bungalow or a high-rise building. Because seismic load acts on the ground horizontally. And as we know, the shaking is like this. So with that, we should design our structure also based on the earthquake load. If you will be asking, ma'am, there is not always an earthquake load, correct? But know also this one, class. If earthquake until now is not predictable, meaning we don't know when and where the earthquake will hit. We don't know where will be the epicenter and how strong the after effects will be. So with that, as future structural engineer, we know this concept. We know that earthquake might happen. We just don't know when or where. It is our responsibility to act by designing our structure based on these common loads. There are still more, but these are the basics. Next, once you know what are the site condition, what is the soil profile, and you know how to analyze the types of loads, now you can design. So with that, there are two steps. You can do the manual computation. That's why you are studying in college of math subjects and concept subject like physics, calculus, and then in your higher years, you will be studying mechanics, statics, dynamics, reinforced concrete design. You are taught in school how to compute manually because you need to understand the concept of it. On the other hand, there are currently design softwares that can aid our manual computation because we want efficiency, and we can now use softwares like ETABS, SAP 2000, STAAD to help us compute faster. But reminder, software can calculate, an engineer must still know what to calculate and why. Because if you will be examining, all of the design softwares depends on the person. As a structural engineer, all the inputs will still be coming from you. and then the design software will just help you for the output. But then, also for the output, as a structural engineer, you should also know how to evaluate the output. You should also know how to check it. Because if you don't know, how can you trust the output of the design software? So remember, there is an aid through design software, but at the end of the day, you should know how to do manual computations. And for the last, we have the construction. Here, class, is structural engineer required on site during construction? Not necessarily, because the one who builds the structure for the construction is the contractor, and the structural engineer role is the one who designs and provides engineering oversight for the structural system. During the construction phase, class, the general task, the bigger task of a structural engineer is done because he did the designing already. From the start, from the first 3 steps, that bigger task is done. But if in case the structural engineer is still involved in construction, it can be with the following roles. You can review structural plans and specifications, inspect critical structural works, address site issues and design changes, coordinate with the construction team, and ensure structural safety and compliance. Because sometimes, since the structural engineer is the one who designs, and then the contractor is the one who builds what has been designed by the structural engineer, the role of the structural engineer, if there is still time to check in construction, is to know if the design is in accordance as per actual. For example, you as a structural engineer, you designed 12 columns. But as you check in actual construction, the columns that was built is only 10. So as a structural engineer, you need to comment on that. You have the power to comment to the contractor that as per your design, it is 12 columns. Because class, that is part of your responsibility as a structural engineer. You sign the plan that the columns is 12. But then in actual, if it's constructed as 10, that is not in accordance with the design. And if in case someday, the building collapse because of that wrong design that is not in accordance made by the contractor, you will be liable as the structural engineer. If you were asking, ma'am, how about the contractor? I designed well as a structural engineer, but then the contractor is the one who didn't build it. Both of you will be liable because you signed it at 12 columns and then you didn't visit it on site. So once in a while, as a structural engineer, it is your responsibility to check your design if it is actually made on site. I hope that helped you understand what do structural engineer do. I hope you learned something from today. See you on our next lecture. Bye!